Good afternoon, everyone, and welcome to this webinar. Thank you all for joining us today. It's my great pleasure to welcome Claudio Iacopino, who leads the Explorer Group at the ESA Lab within the European Space Agency. Claudio has a strong background in AI and space engineering with experience spanning ESA industry and research. So today he will give a talk titled the ESA Lab Explorer Office Overview and Future Activities, where he will share insight into innovation activities and future directions of the Lab in Earth observation. So Claudio, thank you very much for joining us today. The floor is yours.
Thank you very much, and thank you for this nice invitation. So, as mentioned, I'm Claudio Iacopino, and I'm the head of the Lab Explorer Office. I will have a few slides to introduce you about ESA and the Lab, so that you understand exactly what that means, and then we look at our activities. So, first of all, for who doesn't know what ESA means, ESA is the European Space Agency. It's an international organization that was established in the 70s. So we're now more than 50 years of life, and the number of member states has increased over time. We are now 23 member states plus contributing country and associated countries, and these all contributed to a very large organization that in fact spans beyond the let's say the current what is currently understood as, let's say, European Union, because in fact ESA was established even before that. And among our contributing countries, there are also countries like Canada that obviously are not part of the European Union. So you see how these two realities, in fact, are quite different, have different role, different history. But we are, in fact, strong partners in a number of programs. Recently, we just have our new budget that has increased quite well over the past 3 years. That shows the big support we had from our member states. Like, yeah, in fact, you can see all the various distinction between member states. Obviously, depending on thanks to this, depending also the contribution, ESA decided then to locate some of their activity on the respective countries. So we are in fact distributed over different sites. This slide just shows a bit also the distribution in terms of our budget, in terms of our activities. That really shows the spectrum of different topics we handle. In fact, Earth observation, that is what I'm talking about today, is one of the top directorates. So in fact, it's always been one of the leading aspects of the agency. But in fact, this year, thanks to the latest budget, the space transportation and the scientific program, they received an equivalent, no more budget that shows the different priority, how they grow over time. Earth observation is certainly an established one that for which we are leading literally in the world, but obviously the budget also reflects the various priority, as I said. This is just a nice video that has been produced a bit to show what means for Earth observation for ESA. ESA obviously in general develop industrial capability, progress the scientific understanding about our planet in this case. And what this shows really that ESA is at the core a data provider, has always been. We've been looking at creating new data for new observation, to generate new science, to understand better our planet. That obviously then derive many applications that have a commercial dimension, a larger political impact, societal impact of many policies. So this is how ESA, in fact, goes from the data generation that happened through many satellites to the data exploitation and in fact all the various applications. But we usually talk about upstream, That is everything that regards the manufacturing of the satellite, the launching, the operation of them. The midstream that takes care of the ground segment, so the downloading of this data, the processing until creating products that are publicly disseminated. And then we have the downstream that is that takes care how we can best take advantage of this data. So in this picture, you see really the upstream, and you see how this has expanded over the years. It's divided in three main domains: science, Copernicus, and methodology. Science is made of this unique mission that each of them is able to observe what has never been observed before. They are in fact missions that take typically 20, 30 years from design to launch, and they are unique pieces. And for each of new one, there is obviously a big interest from the science community. The Copernicus is our operational service instead. Here, lots of the things that we understood from our Science Explorer mission that can be observed, useful with observed as an application, become then a service for the community. It's a program that is paid by the European Union, and this is what I was mentioning before, the way we are effectively partnered with the European Union, and we operate the satellites for the European Union. And this includes all the Sentinel missions that you must have heard, including also what we call the expansion mission and now the next generation. So it's a very large program that is just getting bigger and bigger. Then we have the meteorological missions that we build for our other sister organization called EUMETSAT, that they operate the satellites, but we take care of all the rest, the construction and launch. So what is the PhilLab? So PhilLab is an innovation lab that operates inside this field of the Earth observation program. We are a bit of a white fly in the sense that we don't really look like any other element in ESA, certainly not in EOP, because ESA in general is a funding agency. So we have the budget that I described before, for which we stimulate the industrial competitiveness. But also we run our program by basically managing projects that are implemented by our industrial or academic partner. In this case, ESA PhilLab does that, but at the same time we do internal research. And that's why it's a proper lab. We actually have the human capacity to run our own research. That in fact become a combination then of internal activity and industrial activity that we procure using the same methods that ESA normally operates. We tend to follow the entire innovation pipeline. We go from a blue sky idea towards a commercial reality. And we do this through literally the conversation, the collaboration of two offices. One is the Explore office, that is the one I lead. And then there is the Invest office that takes care of taking pre-operational ideas and take them to commercial reality. As part of the Explore office, what we do, we really consider different TRL, and we try also to maturate them. So we go from a blue sky idea to maybe TRL 6, if you are familiar with this classification, but just to say pre-operation. Why the idea of the PhilLab? Well, how? First of all, how is PhilLab basically works by acting as a catalyst of innovation. We try to put together different type of expertise, try to connect different lab and academia across Europe and the world. And as such, we allow also ESA to have an understanding of what is innovative, what is coming, what we should invest on. And that is really the biggest function. And this has been, these are a bit of old picture and old numbers, but just to give you the idea, we started in 2018. ESA is we're about 50 members, but in fact we are about 60 members now, and we have done a number of strategic partnership, and certainly there's been many people that pass through the lab, certainly over 200 at the moment. We have been involved in the whole chain I described before, from the upstream to the downstream. And in fact, this slide shows our involvement towards the space mission, the upstream. Here there is a differentiation if the involvement was more in the explore or the invest office, but ultimately we have been consistently delivering innovation in orbit. By the first mission was a FISAT-1, where we had very much the first AI application in orbit that was a cloud mask. And then we had a number of new technology to be demonstrated. Last but not least, in fact, was we just demonstrated before Christmas on the satellite AIX. You can see here on the 2025 at the top. This is a satellite, it's more than one, developed by Planetech. And in here, we have demonstrated that we have now an architecture where we can run a foundation model. Specifically, this is TerraMind Tiny. And the other interesting element of this platform that we have demonstrated is that thanks to the internet satellite link, in this case specifically was towards Iridium, I think, constellation, so a communication as a constellation. This satellite was able to do TNC 24/7 by internet. So we actually were able to open an SSH shell on it. And that is certainly a disruptive, innovative way to command the satellites that, as you can expect, is traditionally only based to the ground link and the opportunities with that. So now I will delve more inside what we do in the office, in the Explore office. We tend to divide our activity according to 3 axes, but that is really just for the purpose of the presentation. The first is the augmented intelligence that is traditionally the largest, because we really started as an AI lab, and over time we have embraced different types of technologies. But as part of those, we certainly work on foundation model, digital assistant, generative AI, agentic AI, explainability, physics informed, and also the combination of this new way to interface with more immersive visualization. Another axis of interest is what we call innovative computing. And here we consider different type of platform, so quantum computing, HPC computing, neuromorphic biocomputing, but also different platform because they are on satellites, so onboard AI and what we call cognitive space. I'll come back on this. And then there is other simply because it really doesn't fit according to these 2 categories. We are quite active now, currently in distributed ledger technology, but in fact we are also interested in also non-ICT innovation that can regard specific payloads, design, different way to do remote sensing in general. So these 3 axes literally are just a big envelope under which we do different various type of activity. But then we have 2 what we call really convergence direction. Convergent because many of these technology come together looking at this specific target. And one is really focused on the downstream. That is what we call a European Earth Agentic Engine. That is basically the idea of putting together that level of technology that can enable a exploitation of the data that is based on foundation model and agentic AI. That in fact is a distributed way to address the problem. And then the other target is related to upstream. and that is what we call cognitive cloud computing in space. And here we are looking at how we basically can deliver something that resembles more of a smart sensor of agents in orbit. But I'll tell you more in a few slides. So let's look now what we do in augmented intelligence. First of all, one of the basic things that really is related to our heritage of data, because ultimately we are still a data provider in the agency. Therefore, we are the first to do something about data, in a sense, if there is an issue with an emission, if there is something we can correct, if we can improve, if we can, in general, make it better for the community. That is where we apply ourselves. Here I'm only showing some of the current activity. There is a huge archive of activities, and in fact, they're not even all the one I'm showing in general in this presentation. Just pick a few, because we do have a large anyway amount of visiting research, so this activity really changes every day. But in general, we are, in fact, there is this topic I call data augmentation, where we say we do everything I just mentioned, how we can make this data more. And we can do it through generative AI, for example, in creating synthetic imagery that can be useful to complement scarce data set that then has many different types of applications. Here, these are just the two projects. I'm not going in details unless you're gonna want to know more, and we come back. Certainly, we are interested here in looking for more multimodal foundation model, where in fact the foundation model will help directly the generation over different modality. And we are already investigating this direction. And then, similarly to what I mentioned before, in fact, is that enhancement. That enhancement really go looking at how we can elevate the quality of our data, how we can remove artifacts, how we can do super resolution, how we do sensor fusion, shadow correction, and so on. Here, in fact, is important project to do in that sense is OpenSR, where we are increasing the resolution of Sentinel-2. We have specific activities in removing biases from biomass data, another downsampling for downscaling, sorry, for water surface, but also different type of things like data fusion for cloud cover monitoring. So, I mean, as I said, we have several type of different application that change every day. Then this is actually an interesting slide because it really shows how we're moving towards that strategic objective we said before, that is this agentic engine. The idea, our overall flagship program that takes care of all foundation model is looking at various direction in a strategic way. This is what this slide shows. So we have from the top interest towards embedding, for which we have done the release and Measure Tom or now nearly 2 years ago already. Here, the embedding world obviously is not finished. We are only at the beginning, so we are doing further activities on how best exploiting them at scale, what are the benefits on different use cases, and so on, different use of them. That this drive also the development of two main foundation model. In fact, as a matter of fact, we're working on more of them, but these are certainly the two more established because we already released them. They are both open source. One is TerraMind, that is a partnership with IBM and DLR. Another one is what we call Tor. Here is in the slide, this still has the project name that is FM4CS, but in fact the model is now called Tor because the consortium is all based in our region, in Norway. The two foundation model here and subjects are in fact quite different. Just to say a few words, the TerraMind is a generative one and it goes across modality. We are expanding it to do even more modalities. In the case of Tor, is very much a fit for different type of mission with a very different resolution. So we are thinking of, in fact, applying to explorer mission and so on. All of this is also very much linked to our benchmarking program, because that we call Pangea. That is well, it's not our initiatives. They didn't start with us, but certainly we have strong contributor. But with Pangea, what we're doing is really creating a benchmarking for this foundation model that is a field expanding very quickly. We are also looking at deploying foundation model on satellite mission, and I already mentioned AIX, but we are also doing the same on FISAT-2. And then we are using embedding foundation model also for our research on LLM, where in fact we have two activities. One is the one really we're pushing for, that is Eve, where we have created an LLM for Earth observation. So it's specialized on Earth observation, and we are now at the phase where we are demonstrating in many different use cases. Okay, here, in fact, I have now a few more details regarding TerraMind. I already mentioned that, okay, it's been trained thanks also to the help of the Jülich supercomputer, based on generative AI. Yes, has this interesting feature called thinking in modality, where basically he gets better prediction by using his generative capability to produce more version of the data in different modality. That somehow helps in describing better the information level of the initial input. So that is a very interesting way of using generative AI. Eve, I already mentioned it, is something that we are now launching. We launched a pilot program for the past few months, and now we are at the phase where, in fact, the release of the model is imminent. As we speak, is going to happen, if not next week, the one after. And following that, we will also release, at least we have plans for a public service of Eve. As you know, running an LLM for the public is very costly. As you know, if you know, but ChatGPT is in a really deep financial trouble. But in our case, obviously, we're not going to open it to 10 million users. There will be a limited quota, but we want for the community to use it, to experiment, to give us feedback. So we're going to run at least something. Eve is interesting because it's the first LLM that has actually been retrained on specific EO documentation. This documentation is the entire Wiley repository. That was only thanks to the collaboration with Wiley. So it's not just what you scrap from the web, just to say. Plus also various ESA resources. The other interesting things of Eve that in doing all of this, we have done, for me, a reference work for what regards respect of data privacy and license, because Eve basically keep tracks of the attribution, but at the same time is able to anonymize and keep track of the way certain document can be used as reference. And finally, just to say last things on Eve, we have an anti-hallucination mechanism that allow Eve really to be quite precise in what it says. So, as I said, we are quite pleased with the result. This was a collaboration done not only with Wiley, but also PySchool and Mistral AI. So the core of this LLM is the Mistral AI, Lesha. And LLM that is a European capability that also make this project quite interesting for us. And we are now in the phase where we are demonstrating its use in various use cases inside ESA. So then the other realm of great interest is explainable AI. This is very important because ESA is interested in operational services, in operational application. And as a result, without explainability, we cannot go very far. So ESA is one of our priority. We know the limitations We've been trying and testing several different techniques, and we have done something like uncertainty quantification. That is certainly something that go in the right direction. We also demonstrated how to basically provide the contest information over certain prediction in a textual form. That is also another way to do it. We run a challenge that was Hyperview 2. And this is really also fit together to the other topic of physically informed neural network, PINs. PINs are very interesting for us because at the end, one of our main stakeholders is science community. And we do work, our lab, as I mentioned before, work a bit horizontally in the entire directory. So we have, among our users, the one working in the science, specifically research. And that is where we believe that PINs could make the difference, because obviously embedding dynamical system equation in various applications can improve the prediction. We're testing this with Greenland sea elevation, with ocean circulation, water basin, evolution of basin water. So these are just examples. There are certainly many use cases, but there are many challenges that goes between how to adapt, in fact, to multi-scale equation, how to scale to real data, because these bits have shown to be not very stable, and but the potential are great. So this is certainly a very important area of research. Then, because of our involvement on operational applications as well and the downstream, we are also looking how the decision maker can best take use of our techniques, our new methods. We have demonstrated this with the flood monitoring, flood risk assessment platform. We have worked with UNICEF on dengue spread. We're working with Save the Children, so with various UN organizations. We have clearly very important stakeholders which we interact, that are so many, I can't even think the number, but obviously here we're not a direct contact with them. There is the whole downstream department looking into this collaboration, but we, as a horizontal technological function, we interact with each of them, providing that technological dimension. And that is really where we believe to make the difference. For example, one of the latest conversations we have is with the IAA, that is the energy agency. With IAA, we are actually, in fact, signing a memorandum of intent. This is, I'm telling you something that's just happening. And they are very interested to see how that observation can help on a variety of problematic that they experience in the energy world, from how to balance energy grids, how to forecast imbalance from the renewable, how to map the distribution of solar panel, how to assess where new solar grids can be built, equivalent to where we can build a new wind farm, and so on. So there are many types of applications. Well, this is something I basically already described, what are our future direction. Certainly for foundation model, I mentioned the multimodality, benchmarking, continuous pre-training for model scaling and embedding, federated learning as well. The other things, I think I mentioned them already, so well skip. And let's now talk about innovative computing paradigm. So in this world, we have a few targeted activities. For example, we work on quantum computing. We are the only one in the agency working in quantum computing for Earth observation. This is a field that is very experimental. As a matter of fact, the TRL here is obviously much lower, but this is where our office is also quite important. in assessing this technology. Quantum computing, I don't know how much you are involved in this and how much you are interested, but is getting year after year, the readiness is increasing, and the current estimate says that by 2-3 years we will have an operational quantum computer. That said, the ways we are going to use it is all to be seen, because they are certainly going to be installed as quantum accelerators in current HPC infrastructure. Some of them are already been installed exactly in this way and are already available. The size of them, however, that is not adequate for an operational problem. But what we're doing here, we're really demonstrating if there are use cases for Earth observation that can run, and there is a benefit from them to run there. Because clearly it is an investment to go in this direction, because the same algorithm has to be rewritten according to a different computational machine. And there are a number of caveats as well. So it's not actually a given that a quantum computer is a faster way to answer to our questions. But as I say, this is something we are investing in a number of activities. We actually, as ESA, also purchased a quantum accelerator that's going to be delivered this year in Nazarene. So we are also going to have a small hardware, but it's, as I say, it's a very small hardware. It's a prototype, as a matter of fact, but it's just to show that things are happening in this world. We're also looking at different way of doing sensing. Neuromorphic is one of them. Neuromorphic are event-based camera, basically, that are designed to be massively parallel and asynchronous, because they resemble the spiking neural architecture. This seems to be ideal for very fast phenomena. That could be, for example, monitoring lightning at night, or some other, let's say, faster respect, let's say, the camera of a satellite's phenomena. But the question here, again, is very similar to the quantum. How worth it is to write software for this type of architecture that is, again, quite different and require this work, this dedicated work. But nevertheless, we are done now what we call it the SysNova campaign. That was basically a call of investigation for very early on study on this. And this year, or the next, we are going to run the first campaign with a neuromorphic camera. A campaign basically means we run an aeroplane, so an airborne remote sensing campaign. So this neuromorphic camera will be under the aeroplane, and we effectively take for the first time a data set. That is going to be certainly a way for the community to work in this field. This is just an excursion now towards our upstream involvement. This was, sorry, VSAT-1 was the first satellite having a chip where we could now run a neural network. And we did this cloud mask algorithm. We demonstrated that is now actually flying on it's going to fly in CHIME, that is one of our Copernicus expansion mission. So this is really a great example of how disruptive innovation that was done back in 2020, it was then take on in our operational mission. And is also on VSAT-2, of course. This was another example where we ran a payload on ISS. This was to automatic detection of virus anomalies or phenomena. This was a first example of really onboard AI in that sense. Here, instead, we ran a first example of containerized technology on missions where we could therefore develop apps that run as a container. And now we have FISA 2. FISA 2, well, it's been launched already in 2024. It will be run for at least another year, if not two. And here we demonstrated a consolidated framework where we had a campaign for people to develop apps that could run then on the satellites. And these have all been now successful. And we are now in a new phase so that we're going to use FISA 2 also for doing dedicated data campaign that can help, for example, the research on doing AI application directly on raw data. That is something certainly quite appealing. We're also going to run a dedicated foundation model for FISAT, but obviously it's quite small because it really runs a small hardware FISAT 2. But so these things are still going to happen and to be demonstrated on FISAT 2. Then, of course, we are also preparing FISAT 3, but that is a different story. Other application on board AI that we do also in other contests, we are researching in optical and in radar. And this is what I just mentioned, the research is done directly on raw data. That is quite of interest because obviously we save a lot of computation resources and data downloads if we can extract what we want directly on board from the raw data. And this is being now demonstrated on the maritime domain in both optical and radar. Fire, we're also looking at radio frequency interference that are interesting for a number of reasons. And we have developed and released also a software called PyNAS that is very much following the output, this activity where we'll be looking at reducing the size of models for specific onboard architecture, obviously by maintaining as much as possible the performance. Towards the cognitive cloud computing in space, this is basically what I mentioned at the beginning, is one of our direction where we want this sort of network of smart satellites. That is a combination of running AI on board, also having inter-satellite link, and having a sort of governance that can allow us to link the ground segment and the space segment. And for this, we are now this year going to launch a larger procurement for really having the first satellite or two part of this constellation that will form this constellation, but then this will grow through different type of paradigms. I'll skip this, as I already mentioned. The last thing here I'm mentioning, I had just a slide on the DLT technology, the distributed ledgers. Here, really, the story is that we believe that this technology can help a number of things. First of all, provenance of data, to certify the provenance of data, but not only. I mean, it can help also in transactions, a bit in the processing chains. Sorry, that, and then collaboration opportunity. So this is an important slide because it shows really the way we work. As I mentioned at the beginning, we don't simply do industrial projects, but what we also do are collaborative activities that are way we engage with the community. And that can be, for example, in the form of a challenge or a sprint where we actually have experts working for a small amount of period on something. A challenge, we have a sort of competition where we provide a problem, we then have an award. We also run the call for ideas. That was a way basically to ask the community for ideas. And then we collaborate, and that's really is the way we work. We collaborate by inviting people over. So we have a visiting research scheme that is open to everyone. And then we have our industrial, let's say, classic procurement methods that we have it as part of ESA. And last slide is really advertisement for the Fin Innovation Summit. That is our large event that will run it now in June, where we'll a bit put on stage all of these and more. And I conclude with a slide for our collaborative innovation network that is basically the framework by which we connect to outside. Thanks to the CHIN, we call it the CHIN, Collaboration Network, we get select or list. I mean, we run all the process that we need to get visiting research. We also have a concept called visiting professor. That is a way to have a more strategic conversation with the senior academic. We take care of our alumni. So this is a bit the Collaborative Innovation Network. If you are interested to come to us for a period of time, please connect to this website and see if there are any call for opportunity currently open, or just submit your unsolicited application. And thank you very much. This is all.
Thank you very much, Claudio, for very interesting presentation. So now the floor is yours, audience, if you have any question or comments.
Yeah, I try to leave some time for questions, so I went a bit faster on some slides.
Hello, can I start? Am my voice clear?
Yes.
Yes.
Yeah. So thank you for your totally increasing interest, attention type of the presentation. That was awesome. And that was lots of different domain to present. So it was hard to find the totally deep in dive relate subject for me. By the way, about the opportunity in the last slide, because I think the majority of the people can gain in their interest in that part. So I find out in your website lots of opportunities there are in the closed session, and there was just one opportunity for binary neural networks. Am I correct? So is it possible to just send some short letter proposal or something like that to say, okay, I find the good connection between my work and your story phase to just join for short time, or event work remotely to just increasing the networking and other stuff. I just, what I mean is just
absolutely
keeping in my mind. Yeah.
I mean, this is exactly what I just described. I mean, we have created this visiting research scheme exactly for this. Consider we are among the very, very few in ESA that can do that. Consider we have currently, in fact, I didn't say this. The lab, as we speak, as today, we are over 40 people in the Explore office, of which 15 are visiting research. So that shows how many external people we have. And these are all people that stays for a period that can go between 3 to 9 months. And that's, I think, is an incredible richness that they bring. Then obviously, I mean, things have to be agreed in a way that makes sense for the period, for the timing. It's all about timing, sometimes, because you may want to work on this, but the people that want to work on the same topic might not have the bandwidth now. You might have to wait a year. It's too much. So sometimes it's about that. Specifically, you mentioned this about the binary network. I believe we have found someone at the moment that will join us, but it does not mean that has to be the only one working on this topic for us. So this is why I say, if you are very motivated to join us, have a number of ideas, we can work together, just email us through the CHIN, and we will, then the CHIN will connect it with the right people, and they will have a thoughts. Consider that in general, the timing, I mean, we're really, bureaucratically speaking, the timing is really short, because it's a very exceptional things for this. But then in practice, we face with a desk issue situation, because we currently don't have desk. and therefore that is really the only limitation over time. And also currently I think we are fully booked until the summer. And so, if you start speaking with us now, we will tell you, okay, and we agree it's going to be from autumn, September onwards. So that's give you the timing that you need to arrange such a thing. Because otherwise I will tell you tomorrow, that's what I'm saying. It really takes bureaucratically no more than a month to arrange everything. But effectively, you need to move 6 months before.
Thank you very much, Claudio.
Thank you for your information. I appreciate that.
I have one question, Claudio. I was very much amazed on AI on board that you showed some examples of cloud masking or detection detection application and so on VSAT 1 and 2.
Okay.
Because most of people in here in our lab and Armando's labs, we work with radar imagery, and we have seen a lot of those RFI or unit-split effects. Do you think that in future this is a capability there that this AI board things could be used for radar imagery or like for cloud masking, cloud detection, or RFI detection, that users can get improved or enhanced SAR data or optical data using these techniques?
These techniques, you mean onboard AI or something specific?
Onboard AI, without dealing with this
more in general. No, well, we believe a lot in onboard AI. I mean, we have been the only one pushing for it from the beginning in ESA. And in fact, VSAT 1 is the example of that. The lab was born with VSAT 1, basically, because it was born in 2018 and 2020 we launched VSAT 1. So if you want, this was really the main target at the beginning. That said, where we are at now I think we are seeing a really nice situation, because we start having hardware that can run AI model certainly not without having to go to platform that are too risky, or I don't need to run the last NVIDIA GPU to run an AI model. I can do with less, and that less gives me some reliability on orbit. Obviously, for foundation model, we're not there yet, and this is where it's really hard. But this means that there are lots of commercial missions that now they just launch the satellite, even if they don't need it. They put in some hardware that can run AI model. And we have seen this with company like Planetech. You say, for me, it costs maybe, I don't know, 10, 50K more, 100, even 100K more to add a module for AI, that the overall budget of the mission is very small. So they just do it, even if they don't know yet for what. And so we are going to see, I think, in the next years, explosion of platform in orbit that can run AI model. And so we are really at the dawn of this. Now, I mean, it's very exciting. And this is why we are coming up with this concept of we call it 3CS, this cloud computing in space. Because we believe that there is certainly appetite to run new concepts on board. When I say concept, I mean generally ConOps. For example, I mean, if we want to say traditional idea is not the tip and Q idea. So a SAR satellite does a detection, understand that this is an interesting target, and communicate it to the pair satellite optic for a very high resolution capture. This has been demonstrated already, right? But not in a very commercial service oriented. So there is still room to do that, but there is room to do much more than that. This is where we believe a network of smart satellite with various different capabilities from sensor and AI level can really be interacting in new way that could be from, for example, taking the image of a target from multiple angles. And so having a 3D reconstruction, or because it's from multiple angles, also being able to go through clouds, because clouds move over time. So you can have a synchronization of imaging opportunity across payloads that ultimately deliver a very different type of service. That's, I'm thinking in this case for emergency, for example, is very important. And you know, we are now moving towards resilience. ESA is moving towards resilience because of the geopolitical context, but ultimately that's just the fuel needs for having more responsive platforms. And responsiveness, agility, resilience, it needs AI, and there is no other option. So I think we're just going to see a lot of investment in that direction. So to answer you, yes, it's a hot topic.
Thank you.
Then there is also the question of the data center. You might, obviously, you know about Musk and so on, they want to build data center. But frankly, I don't connect the two things too much, if not for the hardware dimension. The data center story in space will bring new hardware that has the radiation certificate to run and so on. But from the AI perspective, from all the things I described, is not necessarily addiction, I say.
Very good. Thank you very much, Claudio, for your very comprehensive answer. Armando, you have a question? I think he seems.
If I may,
Yes, please.
this you mentioned very briefly. You were talking about biomass. As soon as you said biomass, I got very excited. What are you doing for biomass?
Okay, biomass specifically, it's one of our big collaboration we have internally, because we are directly involved. We are directly collaborating with the biomass mission manager. We have a fellow working on biomass. So we have a postdoc. He's actually from Brazil. He's one of our international fellows. And he's been working on the bias quantification of the biomass data, but also in general is looking at various other problematic that regards the biomass data. Is now the other thing, I mean, if you are interested to, I can give you the direct contact if you're interested to discuss potential collaboration. The unfortunate thing is that he's leaving in August. So we currently are not going to have a direct, let's say, replacement on research towards biomass. But that doesn't mean that we don't have the needs for. So again, if you want to come to us for work on biomass, you'll find an interface. And the current interface is him, and you can then for sure carry on working on this with somebody else. The other thing I wanted to mention, we are, I think, going to have a sprint on biomass, quite certainly. A sprint is what I defined before, is basically a activity that will run for 3 months using a network of experts. This network of experts, they all are part of what is called FDL. That is in fact a UK thing. So I recommend you to get in touch. FDA stands for Frontier Development Lab, and is a sort of organization that connects academia, many of them in UK, because they are UK based.
Okay.
And it is going to be...
Is it a catapult?
No, it's not Catapult. It's a private one. In fact, sorry, the Trillium is called the company. Trillium UK. Trillium UK, the main project for which you find online is called FDL, Frontier Development Lab. And what is nice, what we like of it, this is a all partner for us, is that have this large network of experts around the world. And so we have always posed them very frontier topics, and they organize them in sprints, and they run it for like 3 months in 3 months. And there is one we just discussing now on biomass.
Okay, that's interesting.
Yeah, so you might want to get in touch as we speak.
Indeed. I remember Catapult was organizing these sprints as well in the UK.
Okay.
Maybe they took all from there. I need to.
I didn't
do
remember
better
this
research.
for the catapult. Yeah, probably is an approach that we have inherited somehow. But yeah, and it's quite nice. I mean, they work on many topics. I mean, they go from foundation model to 3D simulation. Last year we've done one, for example, on literally way to model the dynamic of twisters, and it's quite advanced. Obviously, the TRL is low, but that's what we like it. I mean, we demonstrate really advanced things.
I will look for that. Thank you.
Thank you very much. Everyone else, if you have any questions.
Okay. I do have another meeting. I can just be maybe another minute. What I wanted to say is in, believe 2 weeks, we have another of this meeting. During that meeting, what I suggested to the team was to get some of these researchers to present, some of our fellow, we call them research fellow, the postdoc, effectively, to present. And I was wondering if you have any specific topic you are interested more than the other among everything you've seen today.
Yeah, I think because the majority of people in at University of Western work with radar imagery. If you have anything like AI models for SAR data or SAR enhancement or something like that, it will be interesting. Because you mentioned this Brazilian guy who works on biomass. If he has anything ready to present, maybe it's interesting.
Okay, that's good.
Not only that.
I mean, we do have an exciting things about SAR that I did not mention at all. That is basically we are working on the first SAR only foundation model. That could be of interest also for you, maybe.
Yes, I think this is very interesting. Yes, I think we are looking forward to hearing.
Okay.
Yeah, thanks a lot, Claudio. Yes, I think we just quit the webinar now, and we will be meeting again after 2 weeks. Thank you very much, everyone, for joining.
Thank you. Thank you.
And have a nice day. Have a nice weekend. Bye bye.
Thank you.
Thank you.
Bye bye.
Thank you.
Thank you, everyone.